Proportional relationships. In a proportional relationship, the graph is linear and it must go through the origin. So here we have 4 different graphs. So let's figure out which ones are proportional and which ones are not. So looking at our first one, linear means it's a straight line and it is going through the origin. So this one is proportional. Same with graph 2. It is linear and it is going through the origin, proportional. The third graph is linear, but it does not go through the origin. Both things must be true in order for it to be proportional. So this is not proportional, and the reason does not go through the origin. In the fourth graph, it is going through the origin, however, it is not linear. So again, both parts must be true in order to be a proportional relationship. So not proportional, and this is non-linear. If we have an equation for a proportional relationship, it has to be in the form y equals mx. Nothing can be added or subtracted to the mx. So looking at our equations here, y equals x, y equals 2x, and y equals negative 3x. All 3 of these are in the form y equals mx, so all of these are proportional. Y equals x plus 1. This is not proportional because we have a plus 1, and we cannot have that. So this one is not proportional. And the last equation, y equals 2x squared plus 3. Well, we have an x squared where x should have an exponent of 1, and we're also adding something. So this is also not proportional. Given a table, we can determine if it is a proportional relationship if every y over x is the same or constant. So here we have a table of the number of hours worked, which is our x, and the amount of money earned, which is our y. So we take each y and put it over x. We must get the same thing in order for it to be a proportional relationship. So let's see. Each y over x. So the first y is 12, the first x is 1. So 12 over 1. And then we get 24 over 2, which simplifies to 12 over 1. Next, 48 over 4, which is also 12 over 1. And the last one, 96 over 8, which again simplifies to 12 over 1. So since each y over x is constant, then this is proportional. And it is a good idea, even if the first 2 or 3 come out to be the same, to check all of the values in the table, because sometimes they throw one in where the last y over x makes it not a proportion. All right, so last table, let's go ahead and test it. We need to put each y over x. So the first one is 22 over 1, 30 over 2. Well, 30 over 2 is 15 over 1, not the same as 22 over 1. We could stop here. I'm going to keep going just to prove the point. 36 over 3, that's 12 over 1, again, not the same. 32 over 4, 8 over 1, not the same. 32 over 5 is 6.4 over 1. And then the last y over x is 18 over 6, which is 3 over 1. All of these, again, are not constant, not the same, so this one is not proportional.